This product is a fish tank monitoring system designed to continuously measure key environmental parameters that are critical for fish health. The system monitors temperature, pH, and water level, and allows users to set custom alert thresholds through the Blink mobile or web application. Data is displayed locally on the device, transmitted wirelessly for remote monitoring, and logged to a CSV file for further analysis. In this video, I will demonstrate the hardware, live system operation, alert functionality, and data logging of the fish tank monitoring system. The housing has been designed to open up easily, giving a clear view of all the internal components and wiring inside. Everything is laid out in an accessible way, so it's easy to inspect or service if needed. At the same time, the enclosure is fully sealed when closed, providing strong protection against any splashes or water damage from the tank environment. The design balances waterproof safety with user-friendly access. At the center of the system is the Arduino Nano 33 IoT microcontroller, which processes all sensor data and handles Wi-Fi communication. The system enables a temperature sensor, a pH probe, and a water level sensor, which continuously collect environmental data from the tank. A TFT display provides local visual feedback, and a rotary encoder allows the user to navigate between display screens. An SD card module is included to enable long-term data logging in CSV format, and the system is powered continuously using a mains power supply. To make the readings more reliable, the device doesn't display instant raw values. Instead, it updates measurements every 30 seconds by averaging multiple samples over that time window. This helps reduce random noise and gives a much more stable output. All of the current sensor values are shown locally on the TFT display in real time. The screen provides an easy way to check the tank conditions at a glance without needing to connect to anything externally. Navigation is handled through a rotary encoder, and the user can scroll through different display screens to view each parameter individually, such as temperature, pH, or water level, and quickly return to the main menu. Overall, this local interface allows the system to be monitored directly and conveniently without requiring a phone, laptop, or cloud connection. In addition to the local display, the system transmits a sensor data wirelessly to the Blink platform. Here, the user can view live readings remotely using either the mobile or web application. The user can also set upper and lower threshold values for each parameter. For example, the acceptable temperature range for tropical fish may be set between 24 and 27 degrees Celsius, while for another fish it could be set to another range. These threshold values are sent to the microcontroller in real time and can be updated without restarting the system. If a sensor reading exceeds the defined threshold values, the system automatically triggers an alert. When this occurs, the system sends a push notification via the Blink app as well as an email to alert the user. This ensures that potentially harmful conditions within the fish tank are identified quickly, allowing corrective action to be taken in due time. The system is built around three main sensing modules: water level, temperature, and pH, which provide together a full picture of the tank environment. The water level module is a custom mechanical design based on a potentiometer. A long lever arm is attached to the potentiometer shaft, and at the end of the lever arm is a floating component that moves with the water surface. This float was 3D printed in PLA, and a nut is fixed at the end so its weight can be adjusted. This makes the float customizable, allowing the user to tune buoyancy depending on the fluid being measured. While this project focuses on a fish tank, the same approach could be adapted for other fluid monitoring applications, making the module more robust and versatile. The temperature module uses a waterproof DS18B20 digital sensor, which provides stable and accurate readings of the water temperature over time. Finally, the pH module monitors the acidity of the water, which is essential for maintaining safe conditions in aquatic systems. Together, these three modules form a complete real-time monitoring setup for environmental control and a long-term data logging. In summary, this fish tank monitoring system provides continuous measurement of key environmental parameters, local and remote visualization, automatic alerts, and long-term data logging. The system improves fish welfare by enabling early detection of unsuitable conditions. Potential future improvements could include additional sensors such as dissolved oxygen or automated control of heaters or pump based on sensor feedback.